It's Bobby, and I thought I would show you a typical electric Herm system setup that I normally put together. I build these pretty rarely these days because of the popularity of our single vessel brew in a bag systems and all the all-in-ones that we sell. But a couple of times a year we get to build a three vessel system sort of however we want. We get sort of a blank check from a customer saying to build it how I would build my own system. It's a little bit of a catch-22 because I wouldn't build a three vessel system for myself, but if I were, this is what it would look like. And just a quick note, this is flip-flop from how I normally do it. I usually do hot liquor tank, mash, and boil because I think left to right like I read and write. But circumstances had this have to flip because of the way the customer's room is set up. But we got our hot liquor tank, mash, and boil. And one of the details that you need to know about this system is that it's going to be running off of a 50 amp circuit. So this is the Brew Buddy 2 from Auber Instruments. And this one allows you to run the water heat and the boil all at the same time. So in order to accelerate the startup of your brew day on a system like this, you can heat up your water for your sparge and for your heat exchange, as well as heating up your strike water in this vessel, which is the boil kettle, and have both of those heating at the same time rather than just leaving this element dormant while you're waiting for all the water to heat up over here. So the way that I would normally set this up is I'd fill this up to the top with water a couple inches above the heat exchange coil. These are 15-gallon pots, so I'd probably put like 14 gallons in here. And whatever the software says I need for my strike water to mix into the mash tun with the grain for the first time, that's how much water I would put into the boil kettle. And the way that the hoses are set up is that the you're gonna open up the bottom drain valve that comes out of the hot liquor tank, feeds into the water pump, and then it goes back up to the whirlpool return. Now as the water comes through the pump and goes back into the whirlpool, it's going to keep the water stirred in the hot liquor tank so that the temperature probe installed will always know what the exact current temperature is in that kettle. And so you know, when you turn that pump on, you're going to kind of open up the throttling valve on the pump and let that rip and start heating that up. You're going to set the temperature on this vessel to about 5 degrees above your desired mash temperature, or the first mash temperature in a step mash, or even if it's just a single temperature. Either way, that's what it's going to be, 5 degrees above your desired mash temp. And then over here, what you're going to do is pretty much the same thing. Your bottom drain of the kettle is going to be open, go into the wort pump. This is the wort pump. You're going to open up the valve here so that the pump throws all of its velocity into the whirlpool. That's open as well, and both of these vessels have a whirlpool with a side exit here, so it will stir as it heats up. You'll set the controller for the boil kettle to about 10 degrees Fahrenheit above your desired mash temperature. Okay, so it's going to take a little bit for those to come up to temperature, but as soon as you do, what you're going to do is transfer your strike water from the boil kettle into the mash tun. And you could do this two different ways. One is you can put all of your grain into the mash tun ahead of time, right on top of the false bottom, and you can underlet, which means transfer the strike water into the mash tun underneath the grain and then just stir it when it's all full. Or you can get the water in here first and then stir the grain in. I'd rather do the latter just because I want to make sure that the temperature in here is stabilized and the mash tun gets preheated and whatnot, so that we can hit our desired mash temperature a little bit more accurately, but it works both ways. So let's say we're going to just transfer the water over first. Really important that you close the valve on the whirlpool port because we're going to be disconnecting here. And it's also a good idea to close the valve on the pump. This is going to keep liquid from draining out of any of the hoses. It's going to airlock the hoses. So we're going to disconnect here. You will get a little bit of dribbling here, so a towel on the floor is a good idea. Swivel this over, and we're going to put it on the lower port of the heat exchange coil that's in the hot liquor tank. And the reason we do this, once that's connected, you can open this up. The reason we do this is that the coil is already set up to go into the mash tun. So it's the most convenient way of moving that water over is to just send it right through the coil. And in fact, this is where this hose is going to be for the duration of the mash anyway, so you might as well just put it there. All right, and then now that that's open, we can go ahead and open this up and turn the pump on again. And that will be transferring the strike water through the wort pump into the heat exchange coil. It will coil around inside there, and then it'll come out and go down into the recirculation return hose. And that'll be start floating up on the water as it comes up. Okay, so once all of your strike water is out of the boil kettle, you can turn that pump off, and you can close the drain valve just so you don't have any mishaps later on. You're going to close this throttling valve again to airlock your hose so that the liquid doesn't come out as much. And then the next thing you're going to do is move this hose, swivel it over like this, and just attach it to the bottom drain of the mash tun. The reason we do this is that this is setting up the recirculation loop through the heat exchange coil, which is what makes this a HERM system, a heat exchange recirculating mash system. All right, so we've got this valve open. This would have been closed while you were transferring in that strike water, otherwise this would have been pouring on your shoes. Should have mentioned that. Generally, it's always a good idea to go closing all of your valves anytime you make hose changes, because you only make that mistake once or twice before you realize that water will burn your feet. So we're going to open this up, and you're going to turn that pump on. So you're going to be sending the strike water from the bottom of the mash tun into the wort pump. You're going to open this valve up a bit, about halfway. Then the water comes through here, goes through the heat exchange coil, and goes back into the mash tun. And you're going to set up that loop going, and it's going to stabilize the strike water in the mash tun. Generally, I like to shut the flow of this recirculation loop off before I stir the grain in. So I'd shut that off, stir your grain in, and then get the pump back up again. We've installed a very handy flow meter. This is the Blickman flow meter on here, and as it's recirculating, this red float will rise up in the column, and there's a gauge on here that tells you liters per minute or gallons per minute. And generally, when you run a HERMS of this size, you want to limit your recirculation rate to, just about 2 liters per minute, somewhere between 2 and 3 liters per minute. So that's about here. So the top of this float would just go up to here. If you recirculate faster than that, you run the risk of compacting your mash on top of the false bottom, so to the point where it really doesn't want to drain anymore. So you're not really getting the effect of the heat exchange through the coil that you were actually hoping for in the entire system's design if you compact the mash too much. So you want to limit the speed of that recirculation. You can integrate some rice hulls or go with a slightly more coarse grind on your grain to get a little bit more open flow through on that grain bed. But for starters, try to limit it to about 2 liters per minute or so maximum, so you don't compact the mash. You can go in there and stir every once in a while, see how it's doing. If you can get away with a little bit faster recirc, go ahead and try 2.5 to 3 liters per minute. But I found that slower is better, especially, if you're just trying to maintain a temperature in here. If you're trying to do a big step mash jump, you might want to increase the flow and then occasionally get in there to stir to break up any compaction that happens, at least during that big temperature ramp that you're trying to achieve. Okay, so that's basically this is the position of your entire mash. So you're just stirring your hot liquor tank the entire time, and then you're running the recirculation loop out of the mash, through the pump, through the heat exchange coil, and back to the mash. So you got 2 different loops happening, and you'll run this loop as is for the entire mash. And generally what's going to happen is, this particular controller has 4 temperature readouts. There's a temperature in the hot liquor tank, and this is controlling that hot liquor tank element. You got your boil kettle controller. There's a temperature probe in the kettle, and this is controlling the kettle element. And then this is your passive temperature readout. The way that we have this one set up is the top display is the probe that's in the bottom of the mash tun right at the drain. So this is telling you what the temperature of the mash liquor is on its exit from the mash tun. And then the bottom one here is actually connected to the counterflow wort chiller, which is just a tube-in-tube heat exchanger, and that one is just going to remain at room temperature until we start doing our chilling process. That temperature probe is actually just in an inline T. If you really wanted to get fancy, you can put that somewhere else in the flow. You might measure the temperature of the wort coming out of the heat exchange coil before it goes back on the top of the mash, or you can have a probe installed in the core of the mash, perhaps through a thermal well in the lid. There's a lot of different ways of using that 4th passive readout. There is an alarm setting that you can put onto this controller, but most people just watch it and make sure that the mash liquor is sort of abiding by the temperature of the hot liquor tank. And what I find is that the mash readout is always going to be, say, 3 to 5 Fahrenheit below the hot liquor tank temperature, and that's just what is known as the system offset. If you want 150 degrees in the mash, you got to run the hot liquor tank at about 155, give or take. It fluctuates with seasons, if you have seasons, so that's how you're going to design your mash maintenance temperatures, by just running your hot liquor tank 5 degrees over your mash temperature. And then the last major change in this system is when you're going to start sparging. So you hit your desired pre-boil or your desired mash gravity. You check that the gravity of the wort in this system is not rising anymore. And how would you know that? Well, you can pull a sample out of this valve right here, and use a refractometer or chill it down and use a hydrometer to see if your mash is continuing to trend upwards or if it's sort of plateaued. And then you're gonna run your hot liquor tank up to a mash out temperature. So generally you're going to change your HLT set point to about 175, 180 degrees or so for about the last 20 minutes of the mash. So I'd run maybe 40 minutes at regular mash temperature, and then start cranking up your HLT to about 180 and let your mash ramp up over the next 20 minutes or so. All right, then you're going to shut everything down, all the pumps off, all the heaters off, make sure that you don't make any mistakes. Close all of your valves. It's just a good idea to get in the habit, just close all of your valves when you make hose changes, close everything, okay? So the next thing you're going to do is you're going to run off the mash liquor to the boil kettle now. So you're going to take this, move it over to the whirlpool on your kettle, and you can go ahead and open that valve, and you can open up the mash valve. Okay, and then instead of stirring the hot liquor anymore, you're going to push this through the heat exchange coil. Now this does two things. The first thing is that it already sets up the path to get the sparge water into the mash tun by just doing that one hose change. But you're also going to be running fresh hot water through the heat exchange coil, which already had wort in it, so it will clean the inside of your coil over the course of the sparge. So the first thing I like to do is turn on the flow of sparge water into the mash. So I want to establish about a 1 to 2 inch layer of liquid on top of the grain on here. And as it's coming up, you're going to take your float and you're going to set it on your auto sparge, and you're going to adjust the float so that this closes when there's 2 inches of sparge water on top of your grain. So you're just going to keep testing it. You're going to adjust this and tighten the wing nut with the float installed on there, and you're going to set that so that when there's 2 inches of sparge water on top of your grain, this doesn't flow anymore. You shouldn't see any more sparge water coming out of this end once you have about 1 to 2 inches of water on the top. Okay, so that stops the flow of sparge water. Now you're going to start running your wort off from the mash tun through here. You got your valves open. You turn this pump on, and then you throttle this. You just open this up, and you look inside, and you really just want to run, you know, a nice trickle into there. Pretty slow. It should be coming out of here and just kind of like trickling down the side of the kettle. And what's going to happen is as the level in here drops down, it's going to open the auto sparge slightly and let more sparge water in. So this is the regulator. Basically, you control how fast the entire system runs by throttling the speed of the wort running off to the kettle. And the auto sparge will just follow right behind at the same pace. If this fills up, it will stop the flow. If it drops down, it'll increase the flow. So it maintains that even sparge throughout the entire sparge cycle, which in a system like this on a 10-gallon batch should take about 40 to 45 minutes. And you're going to watch the flow gauge here, the flow meter, and make sure that you're sparging, you know, somewhere around 1.5 liters per minute. So you're going to drop that down, and then it's a very small flow here. And it's a good idea to watch this. There's sometimes something will get through the false bottom and it will plug up the needle valve on here. And you'll notice that because this will drop completely to the bottom, meaning everything has stopped flowing. And if that happens, all you got to do is open that up like 1/2 of a turn and close it another 1/2 a turn, and that will fix that problem. All right, and then you're going to run your whole sparge like that. Generally, what I like to do is as soon as there's enough wort in here to cover that electric element by even 1/4 inch, I go to my boil controller, still set in mash mode, and set this to about 210 Fahrenheit and turn the heater on, again, when the element is covered slightly. And the cool thing about this is that it will keep your wort cranked up. It'll be near boiling at 210 degrees the entire time that you're collecting your sparge runoff. And in fact, about once I get about halfway to my pre-boil volume, I'll even let it start going to a full boil and even start my hopping phase to really cut down on the length of the brew day, because you know that's kind of like one of the downsides to running a system like this, is that it just takes longer to do everything. So every little shortcut you can make will shave a few minutes off your brew day. So that's pretty much it. And once you get all of your wort in the kettle, and this is boiling, then you just shut all of the rest of this down and start cleaning out your mash tun. Now, one of the beauties of the 50 amp controller is that if you wanted to, you could refill this tank to the top and fire this up if you were so ambitious that you wanted to do 2 brew days, 2 batches in a single day. You can have this heating up all the way, and what you would do is you'd put your strike water into the newly cleaned mash tun and get that recirculation loop going, so you can passively heat up strike water in here through the heat exchange coil while this thing is heating up, while you're already boiling the first batch. So you can be on a pretty big head start on your second batch of the day if you're insane. All right, that's pretty much it. The only other phase is when you get to the end of your boil and you want to do a whirlpool. The only thing that really changes, you've already got the wort pump's output going into the whirlpool there. You're going to move the source of the wort pump over to the drain on the boil, like that. And now you can whirlpool your boil kettle, or the other thing you would do is run into the chiller, which is the inputs right there. So all of these hoses are perfectly sized so that there's no extra slack, but they're not tight, so they always have a nice gradual flow into there. One thing I didn't mention was why this little sample valve is so important. When you're fly sparging, generally you don't want your gravity to drop down, your runoff gravity out of the mash tun to drop down, say, below 1.008 specific gravity, because you can extract tannins out of the grain. Generally that's known as over-sparging. So it's nice to be able to pull a little sample out of here while the sparge is happening, because if you take a sample out of the boil kettle proper off the top, the problem is you're just getting sort of the average gravity from the very beginning to where it's at now. But if you take it from here, you're actually measuring the wort runoff, or the liquor runoff here, and you can decide when to cut off your sparge in the rare case where you're about to over sparge and start extracting tannins. You could also take your pH readings from here, things like that. So the only hose missing from this display is the wort coming off of here. You can see this is where the temperature probe is going to be measuring that fourth passive output, and then the wort output to go to your fermenter is down here. Quick disconnect right there. So there's going to be a longer hose that runs from there into your fermenter. All right, that's pretty much the overview. It took 21 minutes to do that, and if you have any questions, let me know.